Hello and welcome back to Saxon Math. This is lesson 79, area of a triangle. In this lesson, we will demonstrate that the area of a triangle is half the area of a parallelogram with the same base and height. So some of the things you might want to use would be a pencil and a paper, a ruler, and scissors. You can fold the paper in half and draw a triangle on the folded paper. While the paper is folded, use your scissors to cut out the triangle so that you have two congruent triangles. What does congruent mean? Equal in size and shape. Arrange the two triangles to form a parallelogram. What fraction of the area of the parallelogram is the area of one of the triangles? We can find that whatever the shape of a triangle, its area is half the area of the parallelogram with the same base and height. So if you were to take those two triangles that you created and form them together, you now see that you have a base and a height. So this height would actually be from here to here. It would have to be a 90-degree angle. Remember, this represents the height. So the height is not going to be on this particular parallelogram. It's not going to be one of these lengths right here. This is not the height because it doesn't form a 90-degree angle. It forms something less than 90 on this side. So you have to make sure that whatever it is, it forms a 90-degree to get the height. And remember, area equals the base times the height in a parallelogram. So let's look at that. So it's simply the base times the height. So the area of a triangle can just be half of that base times height. So if you've got your parallelogram, which the area is base times height, all a parallelogram is two triangles, two equal and congruent triangles. So this triangle here would be like triangle 1, and this would be triangle 2. They're equal in size, but they are both half of that entire parallelogram. So the area of a triangle is very similar to the area of a parallelogram. It's 1/2 of the base times the height, which is what the parallelogram's area is. So since multiplying by 1/2 and dividing by 2 are equivalent operations, the formula may also be written as area equals base times height divided by 2, if you wish to do it that way. In the following examples, we'll use both formulas stated above. From our calculations of the areas of the rectangles and parallelograms, we remember that the base and the height are perpendicular measurements. Remember, they are creating a 90-degree angle. So why are multiplying 1/2 and dividing by 2 equivalent operations? Because if it was multiplying by 1/2, you would simply be multiplying the numerators times the numerators and the denominators times the denominators. And once you get that, then you would recognize that the fraction bar is the division bar. So whatever the numerator it is divided by 2 then. All right, let's look at an example here. So find the area of the triangle at right. So remember, the area of a triangle is 1/2 the base times the height, or if you wish, you can have area equals base times height divided by 2. So you just need to determine what the base is and what the height is. You have three numbers in this triangle. You have 4 centimeters, 5 centimeters, and 8 centimeters. I know that this 8 centimeters is the base, not because it's on the bottom in this case, but because I have this line representing 4 centimeters at a 90-degree angle. This piece of information is irrelevant to this particular equation because this is the height. I have 4 centimeters as the height, so I could plug that in. Area equals 4 centimeters times the base, or the height and the base, doesn't matter what order you put them in, but you've got that, and it's both divided by 2. So if I want to, I could reduce before doing anything. I could say 4 divided by 2 would be the same as 2 over 1, or 8 divided by 2 is the same as 4 over 1, Or I could just do this and recognize this would be 32 divided by 2, whichever way you want to look at it. You do have to remember that centimeters times centimeters is the same as centimeters squared. So the area would then be 32 centimeters squared divided by 2. So the final area of this triangle would be 16 centimeters squared because it's 32 divided by 2. So the area of a figure is expressed in square units. So remember that, square units. Read the abbreviation centimeters squared or square centimeters, you could say. Example 2, find the area of this right triangle. So again, if you have area equals 1/2 base times height, then you can just plug in the values. You need to know what the base is and what the height is. And it doesn't really matter what order you put them in. You just have to know, is the base going to be the 5, the 3, the 4, the height, which ones would it represent? So in this case, I see that these two form a 90-degree angle. This is very important in determining what the base and the height are of this triangle. These two sides form a 90. That means those are the two sides I need to use. This side is irrelevant. So the two sides that form a 90, 3 meters and 4 meters, and also not really relevant is what the base is. Usually the base is the longer one, and so 4 meters we can use as the base. So 4 meters, and that would be times 3 meters. So you have 4 times 3, which is 12, times 1/2. You know what half of 12 is, hopefully. So the area of this would be the same as 6 meters squared, because 4 times 3 is 12. Meters times meters would be meters squared, and half of 12 is 6. So that would be your final answer on that one. All right, let's try some of these. Letter A, find the area of this triangle with a height of 6 feet, a base of 10 feet, and a side length of 7 feet. All right, for letter A, you should have, again, area equals 1/2 base times height. You should always start with your formula so that you know what to plug into each of the locations. Area equals 1/2, and I see that 10 feet is going to be the base, and I see that 6 feet is going to be the height. So I'm going to plug those values in, and I'm going to ignore the 7 feet because that's just the length of one of the sides. Now you can multiply 10 times 6 and get 60 and then take half of that, or you could recognize you could multiply straight across. Half of 10 is 5, and 5 times 6 is 30. So I'd have 30 feet, and the label has to be squared. So for letter A, it would be 30 feet squared, or 30 square feet for the area of this triangle. Letter B. Again, the area equals 1/2 base times height. You could also say base times height divided by 2. So let's just use that formula for this one. So for letter B, I see that this is a 90-degree angle right here. That means I need to use this value and this value for the base and the height. The 10 inches is out the door. We don't need to use it to find the area of the triangle. So this area would then be 6 inches times 8 inches. Remember, parentheses means multiplication, and then whatever those values divided by 2. So 6 times 8 would be 48, and 48 divided by 2 would be 24. So my area would be 24 inches squared, or 24 square inches. Letter C. You have a side of 39 millimeters, a side of 25 millimeters, a height of 15 millimeters, and a base of 56 millimeters. Go ahead and answer what the area of letter C would be. Area equals base times height divided by 2, or 1/2 base times height, whichever formula you chose to do, it doesn't really matter. I'm going to plug in the values. I see that the base is going to be 56 millimeters, and that is multiplied by the height, which is 15 millimeters, divided by 2. Before I multiply this big and get a big number, 56 and 15, instead of multiplying both of those, I see that 56 is divisible by 2 pretty easily. So I could just do that real quick, and I would end up with 25 and 3. So that'd be 28 times 15 if I wanted to do that. Doesn't really matter. Doesn't really make it a whole lot easier, but I see that I can make that 28 times 15, because 50 divided by 2 is 25, 6 divided by 2 is 3, so 25 plus 3 makes 28. I'm going to just do that. So I see 28 times 15 then. When I multiply that out, I get 40. I get 10 here plus that 4. I get 8. I get 2. And I add those together. I end up with 0, 12. I carry the 1. This would be 4. So this would be 420. The area of this would be 420 millimeters squared, or square millimeters, for the area of that triangle in letter C. And letter D, let's do area equals 1/2 of the base times the height. So go ahead and answer that using those values. So for the letter B, or the base, it looks like I would need this 5 centimeters. And I know that because this 5 centimeters is perpendicular to this 6 centimeters measurement. You notice that these are not, these dashed lines means they're not part of the actual triangle, but you have to make it a 90 degree. There is no way to make it a 90 degree right here. So if we went from here to here, this is not the height. You see, the height actually goes all the way up to this point right here. Because the height goes to that point, that's why they just kind of carried it out here. So they're just looking for the measurement of the height. That means we're not going to use 11, because this 6 and this 5 centimeters are both perpendicular sides, or perpendicular measurements. So that's why I have 5 times 6, the base times the height. 5 centimeters and 6 centimeters. So that would be area equaling, and I can see that 6 divided by 2 would be 3, or I could say 5 times 6 is 30, divided by 2 is 15. So 15 square centimeters, or 15 centimeters squared, would be the area of triangle D. And letter E, predict if the height of the triangle in C is doubled to 30 millimeters, would the area double? And calculate to check your prediction. So if you're looking again, you've got area equals 1/2 base times height. And it says if the triangle in C, if this was doubled to 30 millimeters, so like up to this point, let's say, so it went all the way up from here to here, would that double this triangle in area? And you can decide, you just predict. That just means before you do any actual mathematical calculations, what would you say? I would predict no, personally. I would just look at it and I'd say, well, that doesn't look like it's the same area, but let's see if it ends up being correct. In my prediction, it says calculate to check your prediction. So if the height is doubled, I can see that 15 is now 30, and I'm going to, instead of multiplying it times, I've got 28 times 15 now. So if I multiply that out, or sorry, not 28 times 15, but 28 times 30, let's see what happens there. And I'm going to put 30 just off to the side here, so I can use that 0. Feels like maybe my prediction was wrong. I'm just feeling like, oh, maybe it just did double it. It just did multiply it, because 15 times 2 is 30. So yes, it would have done so. So let's put the 0 down here. There's 24 here. 6 plus 2 makes 840. And yeah, it did. It just perfectly doubled that value. So the area is, instead of 420, is now 840, and that's a perfect double. So doubling the height of a triangles is going to give the exactly double the value in the area. So that's exactly what happened. All right. Excellent work today. Make sure when you do your written practice, you do 1 through 30. Remember, Saxon math only works to teach you the skills if you do problems 1 through 30 from the previous lessons. Have a great day.